fifth grade, it's Mrs. Seals back for our next science lab. So the past couple of weeks we've been talking about energy. We are going to continue that today by talking about electrical energy. So your target says, I can demonstrate that the flow of electricity in closed circuits can produce light, heat, or sound. So we started touching on circuits a couple weeks ago when we were talking about conductivity and conductors and insulators, but we are going to continue with that today. Hopefully you remember energy is the ability to cause change or do work. And I gave you the word melts to help you remember the 5 types of energy that we will learn about in 5th grade. The M stands for mechanical, which we talked about last week with the marshmallow shooters. The E is electrical, which we're talking about this week. The L will be light, which we'll do next week. The T is for thermal, which we did with the popcorn kernel. And S was sound, which was the very first one we learned about when we did all those different stations with the pitch and the vibration. So electrical energy is a form of energy produced when electric charges flow through a conductor. Hopefully you remember from the lab on conductivity that a conductor is an object or a substance that allows the flow of energy, in this case electricity. So we said that most metals are very good conductors of electrical energy. Copper is the best, gold and silver are also good conductors, and things like that. The electric current travels in a closed path, and that's what we call an electrical circuit. So when the circuit is closed, the electrical current can flow. You might sometimes hear this called a closed circuit. Other times you'll hear it called a complete circuit. Those things mean the same thing. Look at our diagram right here. We have our power source, which in this case is a battery, and I have the electrons flowing from the battery through this wire, which is a conductor. Inside of the wire is some sort of metal like copper, probably copper. And then remember, it has plastic on the outside to keep us from feeling an electric shock, because plastic is a good insulator. So the electrons flow from the power source through the conductor to what we call, it could be called the load, or it could be called the output device. It's whatever that we are trying to turn on or make work by using the electricity. In this case, it's a light bulb. It could be a fan, it could be a buzzer, it could be charging your cell phone, whatever it is. And then the electrons flow from the load or the output through another conductor back to the power source. So because everything is connected, everything is closed, we have a complete or a closed circuit. The light bulb is able to turn on. We have what we call a constant flow of electrons. Energy can continue to flow. That's why our light bulb was on, or our buzzer would buzz, or our fan would turn on, or whatever it is, okay? Then when the opposite is when the circuit is open, the electrical current cannot flow. This can be called an open circuit or an incomplete circuit. So here's our picture. We have our power source, and we have electrons that can flow through a conductor to the load. But then look, once they get to the load, they have no way to get back to the power source. They can't magically just jump. All right, there has to be something connecting them here, some sort of conductor that the energy can flow through. Since we don't have that, the light bulb is not on. The buzzer wouldn't turn on, the fan wouldn't turn on, because we do not have a constant flow of electrons. Once they get here, they stop. If this was connected, but you disconnected any of these at any other place, it would still be an open or an incomplete circuit. You have to have a constant flow, and we don't have that. So today we are going to practice building some simple circuits. Remember, your target said that you can show that closed circuits can light a light bulb or turn on a buzzer or turn on a fan. So we'll be doing all 3 of those, and then we'll also be adding another part into our circuits called a switch, which I'll talk about more in a minute. So quick reminder, This is not something for you to do at home. Electricity is not safe. Just because we're learning about it in 5th grade does not make us experts. Electricity can be very dangerous. It can hurt you. It can even kill you. This is not something to play around with. Do not start messing with batteries and light bulbs and switches and wires at your house. Hopefully you all understand that. The things that we are using at school in the science lab, the batteries, they are not strong enough to hurt us. So even if something is not connected properly, nobody's going to get hurt, okay? However, please understand that in real life, electricity is dangerous, all right? So just a reminder to create a simple circuit. I have my power source. Oh, make some noise. And we're going to start with the light bulb. So I'm going to take my red light bulb. I'm connecting it to the metal part of the battery holder. Remember, not the plastic, because we need the electrons to flow through those conductors, which is the metal. And I'm connecting it to the metal part of my light bulb holder. Ugh, it's not wanting to stay. All right. And then same thing with my black wire. All right. Hopefully you can see my light bulb is on. That means I have what we call a complete circuit or a closed circuit. My energy is able to flow from my power source through the conductor to the load, back from the load through the conductor to the power source. So I have a complete circuit or a closed circuit. All right. So there is our circuit with a light bulb. Now we're going to see if we can make a buzzer buzz by using electricity. So I'm going to disconnect my light bulb. I still need my power source, and I still need my conductors, my wires. And I don't know if you can see this, but this is a buzzer, and these wires have a little bit of copper coming out of the ends of them. So I'm going to make sure to clip the clips onto the wire, onto the metal part, and not the plastic. The plastic is an insulator. It will stop the flow of electricity, and my buzzer will not buzz. All right, so I'm going to connect my red to my red. And my black, black to my black. And my buzzer is buzzing. I'm going to turn it off because that noise is horrible. So my buzzer was buzzing. It turned on. That means I had a complete circuit or a closed circuit. The electrons were able to flow from my battery through the conductor to the buzzer, which was my load or my output, back through the conductor to the power source, and the buzzer turned on. I'll do it one more time. There we go. All right, enough of that. That noise is terrible. All right, so we lit a light bulb, we made a buzzer buzz, and now we're going to produce heat using a fan, okay? So I kind of made the little propellers on here. I don't know what happened to the original ones, but you get the concept. If everything's hooked up and connected and closed, this fan will turn on. So it already has wires. So let's see if they're strong enough to, I'm connecting my wires. All right, so my fan is on, it is working. So my output device is connected. So that means, again, my energy is able to flow from my power source through my conductor to my load and back through my conductor to my power source. I have a constant flow of electricity. If I disconnect these conductors at any place, I open up that circuit. The circuit is open. So I no longer have a constant flow of electrons. My fan cannot stay on. All right. So we use electricity to create light, sound, and heat. The last thing I'm going to show you, I'm going to add in this component. This is a switch. So this is an on-off switch, similar to a light bulb, okay? So the way this works, it's just think about, sorry, not a light bulb, a light switch. Think about a light switch. When you turn it on, the lights come on or the fan comes on, right? When you turn it off, things turn off. So essentially what you're doing, you are opening and closing a circuit. When you put that switch in the on position, you are completing that circuit so that the electrons can flow, the lights come on. When you turn the light switch in the off position, you are opening up that circuit and the electrons cannot flow anymore. And that's why the lights turn off. So a switch allows a circuit to close and open. All right. So we are going to try this with the light bulb. So I still have my what are they called? Conductors attached to my battery. I'm going to connect my light bulb. I'm going to connect this wire to the metal part of my switch. And same with this one. Now my switch is in the off position. Okay, so even when I connect this, my light bulb is not going to turn on. All right, it's in the off position. Everything is connected, so hopefully when I close this switch, it's going to close the circuit and the light bulb will turn on. And it didn't. All right, so let me check all my connections. Oh, there we go. It came on for a second. Do you see it? It's like, okay. It was blinking on and off, so that means I had a connection. Oh, there we go. Yay! All right, so watch. When I open up my switch, it's in the off position. My light bulb turned off. I opened up the circuit. Now I'm closing my switch. I'm closing the circuit. The electrons can flow. Off, on, off, on. Open circuit, closed circuit. Incomplete circuit, complete circuit. All right, so I'm going to put my switch in the off position so we don't waste our battery, and then we're going to try this with the fan. So again, I'm going to do red on red, black on black, because these are just an extension of the conductors. Everything is connected, so hopefully when I put my switch into the on position, my fan will turn on. And yay, there we go. I have closed the circuit, so now I have a constant flow of electrons. And watch, when I open the switch, it's in the off position, my fan turns off. On position, off position. Closed circuit, open circuit. Complete circuit, incomplete circuit. All right, so I hope that you had fun with learning about electricity. Please remember, electricity is not something for you to do or play with at home. I want you to make sure everybody's safe. Please remember there is a short quiz after this to see what you know about electrical energy and circuits. I hope that you guys had fun, and I will see you next week to talk about light energy. Bye, guys.